Okay, this is our lesson for Math 6.5. We will be working on pages 351 to 356 today. These are story problems. They're sometimes confusing. We're going to get through these the best that we can. It says, how can you use the strategy make a table to solve problems using equivalent fractions? Here we see a picture of Anaya. Anaya is planting a flower garden. The garden will have no more than 12 equal sections. 3/4 of the garden will have daisies. What other fractions could represent the part of the garden that will have daisies? Okay, so what do I need to find? I need to find fractions that could represent the part of the garden that will have daisies. What information do I need to use? Well, we know that 3/4 of the garden will have daisies. The garden that will not have more than 12 equal sections. So how will I use the information? I can make a table to find equivalent fractions. I think some of you could do this in your head. I can make a table. Here they've got it divided up. 3/4, they've got 3 out of 4 shaded. Here we've got 1, 2, 3, 4 also shaded, but let's cut that in half. So now, instead of having 4 parts to the picture, we can have 8 parts to the picture, and we see that 1, 2, 3, 4, 5, 6 are shaded in. You could have also done 4 times 2 is 8, 3 times 2 is 6. Here, we're going to divide into 12ths. So now, instead of having 4 parts or 8 parts, we're going to divide this into 12 parts. And we can see here that 9 out of 12 are shaded in. What other fractions could represent the part of the garden that will have daisies? So it could be 6/8 or 9/12. They are, if it says to explain, they are both equivalent. It's time to go to the bus now. Okay, so that's all we're doing on page 351. Let's turn to page 352. It says 2 friends are knitting scarves. Each scarf has 3 rectangles, and 2/3 of the rectangles have stripes. If the friends are making 10 scarves, how many rectangles do they need? How many rectangles will have stripes? So it says, what do I need to find? Instead of copying that down here, we're just going to underline how many rectangles do they need and how many rectangles will have stripes. We're just going to draw an arrow there. What information do I need to use? Well, we know that each scarf has 3 rectangles. We know that 2/3 of the rectangles are striped, have stripes, and we know that there are 10 scarves. So how will I use the information? You're going to make a table. I'm going to show you how to draw that on your paper right here. Okay, we are going to draw a line going across here, and we're going to put scarves up on top, and we're going to number from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because they're making 10 scarves. So then I'm just going to draw lines going down like this. Okay. And we've got the number of rectangles with stripes. And then we've got the total number of rectangles. So if we start here, with one scarf, we've got 2 out of 3. With 2 scarves, we're just going to double that. That would be 4, 6. Okay, for 3 scarves, you're going to start noticing a pattern here. We got 2/3, 4, 6. Okay, let's take 3 times 2 is 6. 3 times 3 is 9. Okay, for 4 scarves, 2 times 4 is 8. 4 times 3 is 12. And you might notice here a pattern. We're counting by 2's on the top. We're counting by 3's on the bottom. So I could do this pretty quickly and go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then on the bottom, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay, so the answer is 20 out of 30 of the rectangles have stripes. The friends will need to make 30 rectangles and 20 of them will have stripes. So 20 have stripes, and the total number of rectangles is 30. All right. Now we're going to page 353. Keisha is helping plan a race route for a 10-kilometer charity run. The committee wants to set up the following things along the course. So we're going to have some viewing areas at the end of each half of the course. So if you think about a viewing area, you've got one half, and then you could have 2 halves. Water stations are going to be at each 1/5 of the course. So we've got 1/5, 2/5, 3/5, 4/5, 5/5. Then at every 10th of the course, we're going to have some distance markers. So we've got 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, I'm out of room, 8/10, 9/10, and 10/10. Now, identify a relationship. Use a common denominator and find equivalent fractions. Well, the first thing I'm going to notice is that 2 out of 2, 5 out of 5, and 10 out of 10 are all equivalent because they are all whole numbers. Okay. Next up, let's find fractions that are equivalent to 1/2. I don't see any there, but isn't 5 out of 10 equivalent to 1/2? All right. Can I take 2/5 and get tenths? Yes. If I multiply by 2 and I multiply by 2, I get 4/10. Oops, I skipped one. Can I take 1/5 and get a tenth? Yes, by multiplying by 2. 1/5 is equal to 2/10. All right, let's try 3/5. 3/5 multiplied by 2, multiplied by 2, I will get 6/10. All right, 4/5, if I multiply by 2 and multiply by 2, I get 8/10. Okay, identify the locations at which more than one thing will be set up. Circle the locations. Okay, we just did all of that. So, circle all the locations. We did that. So you could say all the viewing areas. You could say both viewing areas, all the water stations, and the distance markers located at 2/10, 4/10, 5/10, 6/10, and 10/10. We've circled it, so I'm good with that one right there. All right, let's go to number 3 down here. 56 students signed up to volunteer for the race. There were 4 equal groups of students, and each group had a different task. How many students were in each group? Okay, this is going to be a division problem. 56. I'm going to switch to a pencil here. Divided by 4. 4 goes into 5 one time. 1 times 4 is 4. I subtract and get 1. Bring down the 6. 4 goes into 16, 14 times. 4 times, sorry. 4 times 4 is 16. Subtract and get 0. So the answer is there will be 14 students in each group. All right, now we're going to page 355. They already did number 1 for you. So we'll go to number 2. Ms. Groves has trays of paints for students in her art class. Each tray has 5 colors, and one of the colors is purple. What fraction of the colors in 20 trays is purple? Okay, so we've got one tray, had 1 out of 5, the color is purple. So we are going to find an equivalent fraction. Oh, you know what? No. Did I skip a page? I did. I am so sorry. Let's go back. I skipped page 354. Let's go back to that page. All right, number 4. Sorry about that. A baker cut a pie in half. Here's my pie, cutting it in half. He cut each half into 3 equal pieces. So we've got 3 pieces on this side, 3 pieces on this side. And then he cut each piece into 2 equal slices. So I've got to divide each slice into 2 equal slices. He sold 6 slices. So 1, 2, 3, 4, 5, 6. Okay, what fraction of the pie did the baker sell? He sold 6 out of, if you counted all the pieces all together, that would be 12. Okay, on number 5 and 6, these are the answers. These 2 were really hard problems, so I'm just going to go ahead and give you the answer. What fraction of the tuna sandwich did he eat? He ate 8/12 or 2/3. For this one, if you've ever been to a carnival, it says Luke threw balls into these buckets at a carnival. The number on the bucket gives the number of points for each throw. What is the least number of throws needed to score exactly 100 points? So if we started with 10 times 9, 10 throws into the 9 bucket, that would give us 90. And then if we did 1, 6, that would give us 6 points. And then if we did 2 more throws of 2, then we'd have 4 points, because 90 plus 6 plus 4 would equal 100. So the amount of throws is 10 plus 1 plus 2. That equals 13 throws. Number 7. Victoria arranges flowers in vases at a restaurant. In each arrangement, 2/3 of the flowers are yellow. What other fractions can represent the part of flowers that are yellow? Shade the models to show your work. Okay, we've got to figure out 2/3 is equal to how many 12ths? Well, I know that 3 times 4 is 12, so 2 times 4 is 8. That means I'm going to shade in 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, here we are divided into 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if the denominator is 9, 3 times 3 is 9, 2 times 3 is 6. So I've got 2, 4, 6. Okay, now we are ready for page 355. So sorry about that. Okay, number 2. So we're back to the paint tray. If I know that 1 times 20 is 20, then I have to do 5 times 20 is equal to how much? Okay. Well, I know that 5 times 2 is 100, and then I put on, or 5 times 2 is 10, and I put on that 0, and I get 100, so I get 20 out of 100. And that's also equals 1/5. Miguel is making an obstacle course for field day. At the end of every 1/6 of the course, there is a tire. At the end of every 1/3 of the course, there is a cone. At the end of every 1/2 of the course, there is a hurdle. At which locations of the course will people need to go through more than one obstacle? Okay, so to help me do this one, I have to list out my fractions: 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. Then I'm going to do my thirds: 1/3, 2/3, and then 3/3. And then 1/2 is 1/2 and 2/2. So at which locations of the course? Well, I know that all my whole numbers are going to be the same. So that's the at the final locations. And then I need to find if there are any more equivalent fractions. All right, can I find another fraction that's equal to 1/2? Well, I know that 3/6, 3 out of 6, is 1/2. So this one, they're going to do this. They're going to need to do more than one thing. Okay. Do I have a fraction that equals 1/3? Well, 1/3 is equal to 2/6. So I know at the 1/3 marker, I'm going to have to do two things. All right, I kind of I scribbled over this one. Let's see, do I have something that will equal 1/6? No. How about 2/3? I know that 2/3 is equal to 4/6. So we're going to do something the same at the 2/3. And we're pretty much out of fractions. So at the 1/2, the 1/3, and the 2/3, and then the final thing on the obstacle course, you'll have to do more than one thing. Number 4. Draw and compare models of 3/4 of a pizza pie and 6/8 of the same pie. All right, so let's draw two circles about the same. I'm going to divide this one into fourths. I'm going to do this one into fourths, but then I'm going to cut each one of those in half. So I have 8s. Okay, 3/4. It's going to be 1, 2, 3. So 1, 2, 3. And we can see that 3/4 is equal to 6/8. And we know that because 4 times 2 is 8 and 3 times 2 is 6. Last page. A used bookstore will trade 2 of its books for 3 of yours. If Val brings in 18 books to trade, how many books can she get from the store? Okay, this is a chart. So if I start on the bottom and I count by 3s, 3, 6, 9, 12, 15, 18, and then for every 3, they're going to trade 2 for every 3 of yours. So 2, 4, 6, 8, 10, 12. So how many books can she get from the store? She can get 12 books. Okay, here's that same kind of problem with the fractions. Every half hour, Naomi stretches her neck. Every 1/3, she stretches her legs. Every 1/6, she stretches her arms. Which part of her body will Naomi stretch when 2/3 of an hour has passed? Well, I know that 2/3 is equal to 4/6. So she's at that point, she is going to be stretching her legs and her arms. At the beginning of the year, the Wong family car had been driven 14,539 miles. At the end of the year, their car had been driven 21,844 miles. How many miles did the Wong family drive their car during that year? Okay, so we're going to take the ending minus what they had at the beginning, and we will get 7,305 miles. Widget Company made 3,600 widgets in 4 hours. They made the same number of widgets each hour. How many widgets did the company make in 1 hour? This is a division problem, so let's use the basic fact here. 4 goes into 36 9 times, and then we're just putting on the 2 zeros there. So that is 900 widgets. Tyler is thinking of a number that is divisible by 2 and by 3. Write another number by which Tyler's number must also be divisible. Well, if it's divisible by 2 and by 3, it's also divisible by 6. Jessica drew a circle divided into 8 equal parts. She shaded 6 of the parts. What fraction is equivalent to the part of the circle that is shaded? Okay, you could have written 6/8, or if you wanted that in the simplest of terms, you would divide by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. And that's all for today. Now you are going to go to Clever and do the 6.5 assignment.